Okay, the last class we have discussed about the linear basics. What is the binary logic gate? What is the gate? Why they given the name as the gate itself? Okay, and also we have seen the what is the meaning of the binary? Okay, binary also. Even we have discussed about some basic gates. Okay, AND gate, OR gate, NOT gate also. And also related to that we have seen the truth table also. And also how the these logic gates have been implemented to the digital real world also we have seen. Okay, the electronics related even we have seen in the electrical field also. Okay, and even today we will discuss the few more logic gates which are the derived form. Okay, we will derive some more, a few more logic gates from the basic gates. These basic gates only. Okay, what are the basic gates? Which what? AND gate, OR gate, and also NOT gate. By the these gates we will be having the few more gates in order to get the simplified form of the digital forms. Okay, we will not write the each and every time we will not use the this type of gates, because if you are using the repeatedly these gates, is what will the redundancy will happen. Redundancy even will get the cost effective is also more. Okay, we will not get the feasibility in the while writing the while designing the circuits. In order to overcome this, we will have the few more logic gates. Okay, we will derive these logic gates from the basic logic gates. Okay, from the basic logic gates only. Okay, if you see the few more logic gates, this is what here the we have any of we have the AND gate. Okay, we will apply the we will have the so AND gate can be converted to NAND gate. This is what here the we are adding the bubble to the front of the gate. Becomes what here the NAND gate. Now OR gate becomes the NOT gate by adding the bubble to it. Because nothing but the bubble is nothing but here what here the it's an inverter. It's an inverter. We will discuss the why these gates are used in the real time, how they will implement our real time world also. Okay, we'll see that now today. Okay, we'll see the concepts. Okay, derived logic gates. And also OR gate and AND gate. Okay, AND automated rear application is here. In your car, okay, in the EV car, you are in any of the cars, all the doors are closed. All the doors are closed. Then only the beeping sound will not come. Okay, sir. Okay, beeping sound will not come. Okay, the car will, okay, if all the four doors are closed, then the beeping sound will not come. That's nothing but the other. What's the nothing but the other? AND operation. We are doing the AND operation there. Okay, or I can say OR operation. If the any, okay, you can also get the real time of the OR operation. Where if the any classes are running in the college, that would be say we can say it's what the college is over. Okay, if the any okay, you can say it's anything. If the one student is attending the class, means what the class is running. Okay, that's nothing but the if any one input is on, any one switch is on, then the output is what the bulb will glow. Otherwise, bulb will not glow. Okay, as you see already this is in the last class. Please here the not gate is also be seen. Okay, in the temperature sensors. Okay, in the temperature. Okay, so many applications. IoTs are working on based on what is the not gate. If the temperature is low, okay, if the temperature is low, then we can say it's a temperature is low. Then we can also amplify that. Okay, we can say it's a amplify. These are the not gates usually used in the fields. I provide the sequence what are the digital circuits can also be used in the real time application. Okay, why? Always, okay, this is all about this. I hope you are clear with this part. Okay, then why? What is the system study the digital circuits? Okay, digital engineering. Why this era is completely this age is a completely digital age. Okay, what we can say. What is the lesson of the engineering? Okay, as a software. Okay, as a computer science engineers also need to work to study the electrical circuits, even electrical circuits. But they are not doing the electrical circuits because only the electrical circuits. Okay. Many of the applications nowadays are working with the electronics only, robotics field, IoTs, and all. They have to work there. No? Then at least as a software, as a CS engineer, you should have to know some of the electronics basics also. So that's what they will do for the first sem basics also they will do the one basic electronics, and also third sem also DDCO, and then the fourth semester micro controller, and also in the fifth sem one more subject is there from digitalized subject, and sixth sem is the extension version of this DDCO here. Okay, and also in seventh sem also we have the IoT also. And it means what each and every semester you will be studying the electronic subjects also. Okay, because you will be working in the companies with the electronics related companies also. Okay, that's what we will be using for studying the electronic subjects also. Okay, you should remember. Okay, now we consider the derived logic gates. I hope you all are clear with this one, because every time you will get the confusion. Why you have to study the electronic subject in the CS student. CS student, why I have to study the digital subjects? Means for the electronic subject means what? You need to work hybrid in this finding the complement of company every day. Some civils companies there, civils company. There are you have to work. Okay, there electronic subjects, electronic components they will be studied. Apart from that, such a situation, you need to know the some basics of the digital also. Okay, just to write it, I will write this one. AND gate. Name, proper symbol. Function and also related to this one is the truth table. D. You should remember. I means what? Just to write the D. Okay. Whatever that we are using these gates here, the having the each and every gate will have the two inputs. You should remember. Okay. What are those inputs are here? The X and Y. X and Y. The output will be what here the F. Okay. And also the algebraic function for this one is here the operator what kind of operator we are using? Dot operator. Okay. Every time you will be using the dot operator related to the AND gate. Okay. AND gate. Okay. Just to write the dot here. Okay. How many inputs are the X and Y? First to write the X and the X and Y. Just to output is what here the F. Okay. Output is what here the F. Okay. You can write. Now table relatives. What is the truth table? Truth table is the table where it's having the input column and the output column. Together variables. Okay. Variables can be represented in the columns X and Y. Okay. And also outputs in the outputs in what here the outputs will be in the column only. The rows means it's to show you giving the rows here. Okay. It's the rows represents the number of combinations of the inputs. Columns represents the variable names and variable. Okay. And the rows represents the combination of the input variables. Okay. We have the two inputs. This is what the 2 to the power of n. Here the n is the number of variables. How many variables are here? Two variables. That's nothing but 2 to the power of 2 is equal to 4. Okay. We have here the how many combinations? 4 combinations. So we can write the 0, 0, 0, 0, 1 as right. Okay. Then the here the what here the dot operator I use here. If the AND operations are always tells us what it is mean. What does it mean? Just if the both inputs are high, then only output is high. Otherwise, it's low. Okay, it shows that it's giving the tell us what does it mean for AND operations will tell us it's nothing but if the both inputs are high, then only output is high. Otherwise, it's 0. Okay, just to put the 1. Both inputs are 1, 1, then the output is 1. Otherwise, it's 0. Okay, it's low. It's low. It means what here the if the two inputs are high, then only output is high. Otherwise, it's low. Okay, that's simple. Two inputs are on, then only output is on. Okay, you should remember. So I hope you all follow this one. Okay, next one I will R. Okay, R is symbol is representation is what here the just okay. Inward side. Okay, this part is inward side. The inputs are here X and Y. Output is what here the F. The algebraic function for related to this one is what here the main operator is here the plus operator. Okay, plus operator. So just to write the plus here. Plus here. How many inputs are there? Two inputs are there. Just to write the inputs is X and Y. Okay, X and Y. Okay, this is the output the R. Then I will be writing the some two table for this one. How many inputs are there? Two inputs, X and Y. Output is what here the F. Okay. The combination of how many inputs are there? Two. Okay. 2 to the power of 2 is nothing but 4 combinations. Same as it is 0, 0, 0, 1, 0, 1, 1. Yes, sir. Okay. Here the plus operator is nothing but here the we will be having the if any one input is high, then the output is high. Otherwise, it's low. Any one input is 1 means what here the both inputs are 0. Just put the 0. If any one input is there, just put 1. Here the first input is high, then the 1. So both inputs are here 0. Expressed to be 1. It means what here the if any one input, okay, if the both inputs are also high, then the output is also high. It means what here the both. It is not necessary to have at least one input. I showed that at least one input is high, then the both output is high. It means what here both inputs are high, then definitely the output is also high. Okay, next is what here the not gate. Not gate here the one buffer, just a buffer. I'm writing buffer property representation. The input is what is the X. Okay, output is what is the X bar or X dash. Just is it complete? No. Just to put the one bubble in this one of this. The bubble, if you put the bubble, that is showing this negative form. Okay, that's negative form of the input. It's the complement form of the input. Okay, that's nothing but here the I have just written the F. complement form of the input. Just as we have the input as the x, and output is the complement form of the input that will be x dash. X, y. Say x, it's the f. Okay, x, f. How many inputs are there? Only one input is there. Only one input is there. Only one input is there for the 2 to the power of 1 is there for the two combinations. Okay, one input having the 0 or 1. The output is what complement of the input form. Okay, that's the 0 as becomes what here the 1 has becomes the 0. Okay, this is all very simple. You know this easy understand very particular. But these are the many of the students after completion of their DDCO third semester also they will tell the how many inputs for the input gate. Not gate means what they will tell 6, 4, 2 something they will sell in the lab exams. Okay, I will ask the questions related to this subject because we have the integrated lab. They will guide asking these questions only. Many students tell us they will tell the how many inputs for the not gate is what. But remember the not gate is having only one input. Other gates will have more than one input. But only one gate that is having the one input is ready. That's the not gate. You should do it. Okay, I hope you all copy this one. also write as the set y 0 0 1 complement of x plus y square. There also difference 1 1
y dash.
xy. Okay, xy is what here the x. I will write it one more time. X y dash y dash. Okay, yes sir. X dash is what 1 1 0 0. Y dash is what here the 1 0 1 0. Yes, sir. I need here what here the x y dash. I need here what here the x y dash. Yes sir. X y dash. Okay, x is here the 0. Y dash is here 1. 0 1 is what here the 0. Okay, because here using the dot operator here. You are using the dot operator. Just to look at here dot operator. That's simply for the multiplication we are doing. In simple, we will not say the multiplication because we are dealing with here what is the algebraic function with the Boolean functions. Okay, that's what I will not use the always multiplication. I will be using the product form or else it is to be or operation. And operation. Okay, it's the and operation. So I will consider the 0 1 is equal to 0 0 is equal to 0 only. Okay, x y dash. X is the 1, y dash is what here the 1. So the 1 in x is 1, y dash is 0. So that becomes what 0. Similarly, I have to convert this x dash y also x dash y. I will consider it with the first with the column of the x dash and also column of the y. Just to make the multiplication, look at product from the 0 1 1 0 what it will be. That is to be what here 0 1 0. This is 0 only. Yes sir. Yes sir. I hope you are following this. Okay. Then this is what the xy dash plus xy dash. Now I will make this what here the another column here f equals to xy dash plus x dash y. Yes sir. Okay, that's the plus symbol. That's the symbol plus operator here. That's the symbol here what we are calling or operation here. Or operations. So or operations is equal to if the anyone input is high, then the output is what high. Otherwise, it's 0. If the other how many inputs are high, no inputs are high. If the other one input is that's what 1. If the other one input is high, that's what 1. It's simply putting here 0. Just okay. It's simple, very simple. Very important. You can say it's what we are just to see there. If the both inputs are low or both inputs are high, then the output is what here the low. Otherwise, it should be 0. If the both inputs are low, if the both inputs are high, then the output is what here the low only. Otherwise, it should be high. You should remember. If the inputs to the logic gate is high, then the output is what here the low. If the inputs are to the all the inputs to the logic gate they are low, then the output is high. Otherwise, it should be low. You should remember. Just to remember that if the both inputs are high, both inputs are low, then the output is always low only. Okay, you should remember this. This is about the x naught. Just I will check in here only to the x naught. Just I am adding here the only bubble to this front of this logic gate. Okay, this becomes what here the x naught. Yes sir. X naught. This should be.
If it's not, it's not triangle. This shape should be triangle if it is not. Shape.
Shape. This is not a triangle.
It should come triangle.
Triangle form. What is it? Let's say triangle form. Just I will have the whatever I will teaching you, that's all the syllabus only. I will not teach other than the syllabus. Okay, just to reference. Then you have to go. This is the concept of the x naught here. X naught is there. Just to reference. X naught, okay? Now I will be changing this x naught to x naught. Okay, just I am adding the n to here and also changing the 7 to 8 and also just I am adding the front of the x naught to the bubble. Okay, what is the if I add the bubble, then the whole form will become functionless. It becomes what is the complement form. Yes sir, complement form. Then I will add with this one is there what be here what is the complement form. Okay, just this complement form. I can write this one to be higher or here what here the x y plus x dash y dash. Okay, this can be written in the x y, because if you open this one, okay, this is if you expanded this one, you will get this form also. Okay, I will explain this one in the coming classes. While using the De Morgan's theorem, I can prove this one. Okay, just copy here. Okay, just I will be making the changes here. Okay, just the making the changes here. The x when adding the not form the output of the x star, and also we will be getting the x star. Okay, x star output is what complement of the x star. Just change the 1 0 to 1 0 0 1 also. Okay, 1 to 0 0 to 1. Okay, x star. These are all basic things. Okay, why I need to explain here in next coming classes, I will not not explain each and every task here whatever I will do. Just time if I use the XOR, there will get the if the both the inputs are low or both inputs are high, then the output is what always low voltage. You should be I'm using those kind of words there. Okay, you should have I would not repeat all these two tables and all there. Okay, just I will be moving it. Okay. These are all about the some basic gates with the derived gates also. Okay, derived gates also. I hope you all clear with this one. Shall I move to the next topic? Boolean algebra. Okay. In order to get the simplified form of the logic combinations, okay, actually the functions, okay, usually the basic logic gates are there how many? 3. Derived forms are around 6, okay, around 6. While using these basic gates and derived forms, we can build a digital circuits, okay, digital circuits, okay. If you want to work with the digital circuits, I should have to have the feasibility there, and also I should have to the cost effectiveness also, economic also I need to know this one. Okay, in order to get the feasibility and the cost effectiveness side, I should not get the complex circuits there. Okay, I should not get the complex circuits. Yes, so if I am going to start without knowledge, okay, familiar knowledge about this logic gates and all, if I start writing the all the logic gates together. I am going to be using the repeated the logic gates. Sometimes I will be using the some lack of knowledge. I will be using the basic gates, derived gates. Some more I will be using the some more complex form. This will give the will not give the economic, good economic, and also it will not give the feasibility also. In order to avoid this one, I will go to simplified form of the Boolean logic gates, Boolean functions. Boolean functions. In order to go for the simplified form of the Boolean functions, I should not get the any confusion between the these things. Okay, logic gates and all. I should have some knowledge about the theorems and postulates, and also I should have to go for some other techniques like the KMF and all. But in the for your syllabus, we have to introduce how to simplify the Boolean functions with the postulates and theorems, Boolean postulates and also theorems. Just I am writing those things. First, to write copy this one. Okay, Boolean algebra will give the functions. Okay, functions. These functions can be complex forms. Okay, in order to avoid this complexity in the designing the digital circuits, I would have to simplified form. I need to get the simplified form of the Boolean algebra, Boolean functions. In order to get the Boolean functions with the simplified form, that is to be simplified with the some theorems are there and also postulates are there. Some postulates, assumption, postulates are there. Some assumptions. Okay, zero the assume ಮಾಡ್ತೇವೆ ಏನಿಲ್ಲ ಅಂತ assume ಮಾಡ್ತೇವೆ. First imaginary thing, zero the ಏನಿಲ್ಲ ಅಂತ. One number something is there. It's assumption. That's the postulate. Okay, if I use these assumptions or that's the postulates with the some simplified form. Okay, zero plus zero again after it should be what we have the zero only. It's theorem. What we say? Okay, it's fit to answer. Zero plus zero is zero we already know this one. This one we call the theorems. Okay, this is called the theorems. Postulates is the postulates are nothing but what are the assumptions. Okay. Assumptions. What we are assuming here? What we are assuming here? Boolean variable can have the two values. Those are what values? 0 or 1. It's the assumption. It's the assumptions. Okay. 0 or 1. Postulates means what theorems are nothing but if I add the 0.0, okay, that's nothing but if I use the AND gate, then the output is what here the 0 only. If I use the OR gate, 0 plus 1 is what here the output is what here the 1. These are the some okay, these are the conditions. Okay, already we did this one. We say we can say this things as the theorems. Okay, this can be theorems, this can be assumptions. Some assumptions and theorems are there, so that we write those things in the table form. Only you should remember while solving this one. Okay, then and off form, okay, and form. Okay, if I write some assumptions, I make some assumptions and also I will be writing some identity law is there. Identity law. First law is what? Identity law. Identity law. Identity law says that if any variable to be added to with the 0, then the same will be what here the output as input as the output itself. Okay, that's the off form and writing here. 0 plus a is equal to what? A only. Then if you are writing the dual form, that's nothing but the AND form. The duality is nothing but we are changing the off form to AND form, off forms to AND form, and also we are going to change the zeros to ones, ones to 0. That's nothing but the duality form of the array function. Okay, AND form may be the off form may be the off form may be the AND form may be the. But thing is that if you are changing the AND form to off form to AND form, and zeros to 1, ones to 0, that one is called the duality of that particular function. Okay, here the function is what here the 0 plus a is what here 0. If I am going to AND form of the duality of dual of this function is what here the 1 is 0 becomes what here the 1, plus becomes what here the dot, a becomes what variable remains same as it is, then the a is what here the a only. Yes, sir. Yeah, one product form of A is what we have A. That's nothing but what I'm going to say here. What is the product form is the R form to I form. Okay, do it in order to do it, I have two conditions here. Just to change the make changes of the R to and to R form, and also I have one more condition is here that we have to change. Okay, we make the changes 0 to 1, 1 to 0. Then only we get the dual of the particular operation, that particular function. Okay, I need every time. Okay, this one. Okay, just I will be writing the only one part. Then you will be writing in the second part. This is dual of this. First form you can say it's first form, say dual form. This is R form or I form. And form whatever it may be, very good. But thing is that I consider this first form as the R only. That's the first one. First form dual form. Just I will write not writing that one. You need to write. Okay, one law. Okay, next identity law shows that always the function. Okay, wherever you put the 0, that's when you will get the output as the same. Even the dual of this one is what is the same. 0, 1, 1. Boolean function. Another two variables, two values that is added to the variable. The output is what is the same as the variable. Same as the variable. Next is what null law. One plus A is what here the 1. If I found anywhere the 1 plus A is there, then the output is always 1. Just to dual form, how to write the dual form? 0 as it is A, it's 1 to 0. This is the dual of this one. Yes, sir. Okay, similarly, I will be writing the item putting law. This is what third law is what item putting law. Item putting law is there. A function is the same, variable is the same, then the output is what is the same only. Okay, 1 plus 1. Okay, Boolean algebra is what here the Boolean values. Boolean logic is the 1 plus 1 is what here the Boolean logic. Plus operator is what we which logic get? Plus operator is there. Which related to what you not get? OR gate. Okay, 1 plus 1 is what here the OR operation we are performing. That's equal to 1 plus 1 is what here the 1 only. Okay, they are doing the same. They are doing the here the 1 plus 1 is what here the 1 only. 0 plus 0 is what the 0 only. Similarly, if I deal with the same A dot A is what here the A only. Just I am changing the plus 2 and also we don't have the any zeros or 1. Just I am making the writing the A dot A is equal to A only. Okay, 1 into 1 is what? 1 product form. 1 dot 1 is what here the 1. 1 dot 0 is what here the 0 only. That's nothing but here the if the both the inputs are same here the output is also same here. This we call the item putting law. Okay, item putting law. Okay. Next is what here the inverse law. Inverse law. A plus A dash is given there what is the 1. Okay, A plus A dash is 1. This I will be using. Okay, this inverse law I will be using every time in the Boolean function. While minimizing the Boolean function, I will be using this A plus A dash is the form. Okay, you should remember. And even just I will be making the dual form. How to write it? A plus going to be changed what is the dual form plus 2 dot. Okay, R2 and form. R2 and form. And the A dash is same as it is A dash. Okay, 1 becomes what here? 1 has to be changed what here? 0. 1 has to become what here? 0. How? If you are 1, if I have the inputs as variable, having the variable A, having the value as the 1, the inverse of this A is what here? 1 is what here? 0. 1 dot 0 is what? 0. If I have the 0, 1 inverse is 1. That's nothing but always I will get the A dot A dash is nothing but the 0 only. A dot A is getting always with the 1 only. You should remember. If you know that this column is R forms, definitely you will write the, you can remember the and forms. That's the dual of the first form. Dual of the first form. Okay, I am using, okay, I will tell you, I will simplify the Boolean function. Okay, I need this table. Okay, Okay, commutative law. Commutative law always says that if the input combination can be interchanged here, then the output is also same as the input only. Okay, just writing here the a plus b, a plus b, a plus b. Just writing the a plus b. All forms I am writing the all forms only. Let's come from a plus b. Then you can say it's what here b plus a also. You can interchange the values. The output is not be able to change. It's the same as the input only. Okay. E1. You can also write the ion forms as the ion form will be what here the a as it is. Just to change the dot b. This is b as it is. B dot a. A b equals to b. A b equals to b. Okay, these are the commutative law. And even if I say the I will this one. Okay, this next one is what here the associative law. Associative law. Okay, associative law is nothing here the I have the three inputs here. Okay, great engineers. Okay, great mind people should not talk anything here. If you want to discuss, just communicate. Okay, please don't talk. I don't want to hear the students have to fast talk. In the event also, just ask them. Because the information is not important. Okay, associative law deals with the three variables a plus b, a plus c. You can also write the a plus b plus c. This is what I call the associative law. You can also write the a dot abc plus a is equal to ab. Okay, sir. Is it clear? Yes. Okay, next thing is what here the distributive law. Distributive law. Here the I have the distributive law is nothing but a b plus c. A b plus b is nothing but the I can expand this one. So what the a b plus ac. A b plus ac. Okay, similarly I can write it in the ion form. That's nothing but the a plus bc equal to ab. A B will become ion formula हो गया. Dot is the multiply there with the a plus b. Dot plus is there with the plus a plus c. What a plus okay. Next absorption law. Next what is the absorption law? Absorption law. Nothing but the a plus ab. I am using this part rigorously in the coming classes. Just to remember a plus ab. I can also write it is the a of 1 plus b. 1 plus b is what here? 1 plus b. 1 plus b is here. What is that? 1. What is that? 1. What is that? A 1. A dot 1 is what here? 1 dot a or a dot 1. This is the total a only. This is the a. Then the output is what here? A only. Yes, sir? Yes. Okay, I can also do these theorems and all with the by using the some calculates and also by the theorems also. You can also do. I am not doing here. They are asked in the examination. Okay, do also. Okay, just to do these theorems. These theorems. Okay, I will be taking those proofing and all in the next coming process. Just to remember. Okay, I can also write in the dual form anything. A dot a plus b. That's equal to what here the a only. Okay, next one is what I is before one is theorem. Devereux law. Devereux theorem. Devereux theorem. What Devereux theorem? A plus B. Okay, whole bar equals to A bar dot B bar. It means what here? Just going to change A plus 2 dot. Just put the dot to the each and every element here. Okay, this is what the Devereux theorem. And also I can write this in the dual form as the A dot B whole bar equals to A bar plus B bar. This is also Devereux theorem can also have the three variables, four variables also. With the explanation they ask in the three variables. Just to apply the Devereux theorem, just to simplify the given Boolean solution. How to simplify the Boolean solution is the Devereux theorem. Just they ask write the dual form also, and even they can also write the they will ask for the explanation. Just to simplify the Boolean function with the theorems and postulates. They will ask. Okay, while asking, okay, such just to remember there is 9 laws. Okay, I'll be dealing with the next coming classes with the some simplification of Boolean functions by using these theorems and postulates. Okay, this they will ask for the 10 marks also. Okay, by using the Boolean function, Boolean theorems and the postulates, simplify the given Boolean function. Given Boolean function. One Boolean function ಕೊಟ್ಟಿದ್ದಾರೆ ಅದನ್ನು ಸಿಂಪ್ಲಿಫೈ ಮಾಡೋದು. Okay, we simplify one Boolean function. Just 2 minutes I will simplify one Boolean function.